So thank you very much. Thank you all for coming. Thank Ute for inviting me. So this is a slight detour from what we heard so far. Of course, DEI will join at the end, and this is what I do for a living. I study nanoscale systems out of equilibrium. My office is right above our heads. So I study things like photosynthetic systems and nanoparticles that shine light on them, and something called molecular junctions, which is basically electronic wires made of single molecules. This is what I do for a living, which kind of begs the question, what qualifies me to talk in front of this audience? And so there are three parts to the answer. The first is that for some reason, I'm not sure, even in my scientific work, I tend to go against the flow. I don't know why this happens. Maybe it's a trait of character, but maybe it's genetic. You can see titles like, is photosynthetic complexes use quantum coherence to enhance efficiency? Probably not, which might, make some people angry. And this is a William of Ockham, and this is a picture from one of our abstract figures. So in a lot of my work kind of pushed me against the current. So I have a little feeling of how it feels like to go against the current. The other thing is that I'm a fairly outspoken climate realist or climate skeptic or a climate rationalist, and I speak quite openly against catastrophic climate change. I've become somewhat of a persona in Israel public life, so much that former member of Knesset Alon Tal compared inviting me to a conference like inviting a Holocaust denier to a European jury conference. So I kind of know how it feels like to go against the common party line. The third qualification is that I actually teach philosophy of science, and I do this from the viewpoint of a practitioner, which is since that's what I do for a living. And thinking about philosophy of science in the last couple of years kind of led me to rethink what it is that I'm doing, or what it was that I was doing for the last 15 years, and shine a light on this. For example, it led us to write a paper which questions the methodology of papers like the famous 99% consensus on climate change and things like that. This is now under review, so I hope it will be out soon. So what I want to talk to you about is biases in the knowledge system. And this is what I would call an applied epistemology issue. And it's very, very important, I think. And it's related to everything that we've heard and already going to hear. And I have to tell a little story. I'm here at BGU. I grew up here. My father was a professor. He was a physical nuclear physicist in the nuclear engineering department. And as a young kid, I roamed the halls of the university. You come in, you see these big building, people walking around, with their heads. And I didn't really understand what's going on here. So as I grew up a little bit, I asked him, Dad, what's this place? So he told me, and this is a true story. My mother is here in the audience, so she can corroborate. Son, the university is a place that accumulates knowledge. That's a strange thing. So I asked him, how do they do that? So he told me, when students come into the university, they know very little. When they leave the university, they know nothing. The difference was accumulated by the university. So, of course, this is an interesting way to look at academia, but it's really important to try to understand what it is that we are doing here. And to do that, all you need to do is go to the ethics code of BGU. There's a written document called BGU Ethics Code, and the first statement is what the university is. And the fundamental aim of the university is to seek, investigate, and teach the truth, to promote all fields of knowledge. And everything else is derived from that. So the goal, the aim of the university is written. We know what it is. It is to seek, investigate, and teach the truth. Of course, truth and knowledge are things that we need to understand. And Andrea already talked about this, so you made my life a little easier. I can switch through this fairly fast, right? What is truth? Well, we kind of understand, and I'm not going to go deep into the philosophy here. In mathematics, it's very easy. Truth is any statement that comes out of the axioms, right? You can prove something and then it's true. In the physical sciences, it's a little more delicate. Truth is a statement reflecting observations of the world. In Spinoza's language, this is facie naturae, the face of nature. What is true. If you've measured it, then the measurement outcome is the truth. Of course, this has limitations and so on, but we kind of understand what true is. It's what is true. All the rest are, the stories we tell ourselves. So truth is one side of the thing, and knowledge, right? We need to pursue knowledge in the university. That's the aim. So how do we know things, right? This is epistemology 101. Well, there are basically 4 ways of knowing things. One is knowledge from the divine. If you are lucky enough, you will receive knowledge, directly from the divine. That's not very common. So we're not going to use that a lot. A much more common practice is knowledge from authority, right? Someone heard it from the divine and is passing it on to us. Of course, these ways of knowing are not very useful to science, right? We all know this. So we need to use other ways of knowing. And there are 2 major ways of actually knowing things in the scientific method. Is knowledge by observation. This is Miran. He was a former student in our lab, and he's actually observing nanoscale particles through a microscope. So knowledge by observation. We look at the world around us and we see the truth, because what we see is the truth by definition, right? So observation is one thing. And of course, the 4th way of knowing, which is as important as observation, is logic. And this is my student explaining to my postdoc through logical arguments what happens when you pass current through a molecular junction, and I have no idea what they're talking about. This is typically the case, but the use of logic is essential, right? This is the tool that we use to explain the observation as part of the scientific method. So the never-ending circle of scientific inquiry can really be summarized very simply. And of course, you can be a hardcore Popperian or a Kuhnian or anything in this spectrum, but you would understand that the cycle is always the same. You have an observation. You have an observation. You use logic, right, to come up with a thesis. What is a thesis? It's an explanation to the observation based on general rules. In physics, we call them laws of nature, but you can use other forms of basic rules. And you again use logic to generate from this thesis some kind of prediction, what you should also see. And then you test this with a new observation or with an old observation, and you either corroborate the thesis or falsify it, right? This is the kind of the standard tool for any science and any field of inquiry in general. And of course, there are deviations and there are arguments on the limits, and it's just, but basically, this is the story, the never-ending story of the scientific inquiry. Of course, this only happens in the ivory tower of academia, right? This is how I try to do things, and some of the people here who are in academia, but we are not an ivory tower. This is not an island. You cross the street and you are in the city. And the question is not how do me as a scientist know things? That's an important question, but it's not the question I want to talk about. The question I want to talk about is how do people know? How does the public know things? That's a whole different question, because the typical person is not a scientist. Thank God for that. So there are other ways that the public gets its knowledge. And this is generally dubbed the knowledge system. This is a term coined by Alex Epstein, who's a philosopher and talks a lot about energy and things like that. And the knowledge system is the system of institutions in which the population receives this knowledge. And Alex divides it into 4 parts. The first part is us, the researchers, right? We do the basic science. We use the tools of observation and logic to generate a knowledge. And then there are the synthesizers, right? The people who look at all the science that was gathered, all the information, the knowledge that was gathered by researchers, and synthesizes into reports or into books or into things like that. And they kind of synthesize these things. And there are many, many examples. For example, government committees or public forums or private companies who generate reports, things like that. Since I'm in the climate business for a while, I will be mostly giving examples from the climate discussion. So the climate discussion, the main synthesizer we know is the IPCC, the Intergovernmental Panel for Climate Change. And I will give some examples. And after the synthesizer, there are the disseminators, the people who take this information and actually spread it around. And these are, of course, news outlets, media, social media, teachers, things like that. And the final link is the evaluator, the people who take this knowledge. And of course, they are also take this knowledge not directly from the researchers, that's very, very rare, but they take it from other sources, and they say, okay, what to do with this knowledge? So these are the 4 pillars of the knowledge system. And Alex Epstein kind of imagines this as a linear chain where information flows from the researchers to the synthesizers to disseminators and evaluators. And he highlights, and of course, each part of this system is composed of humans. And humans are prior to incentives and biases. For example, in researchers, this is well known, we all feel it, and many of us feel it, are prone to academic pressures, peer pressure, political bias, funding bias, and status bias, right? We all want to do well. Synthesizers, of course, are also have incentives of their own. They are limited, first of all, by the knowledge accumulated by the researchers. So that's also a certain bias. Of course, political bias, because these are committees and there's public attention. If you are in a committee, you want people to listen to you. So that's another incentive or bias. And of course, the bias of self-preservation, again, given the example of climate. And I'm not saying anything about, CO2 in the atmosphere at this point. I'm just pointing to the general structure. If there is a committee, right, whose charter is to discuss the dangers of climate change to humanity, right, and this is written in the charter, what are the chances that the committee will say there are no dangers? You can dismantle this committee, right? The probability for that is very, very small, especially if it's funded by millions of dollars. So it's an inherent bias. I mean, it doesn't mean that what they say is going to be wrong, but it is a bias, and it's in every committee. Every synthesizer has this kind of bias. Of course, the disseminators have completely different incentives and biases. They have political agenda, and they have, of course, financial incentives, and these are all intertwined with one another. And eventually, the evaluators, they have politics and agenda, and they have the popular vote. They need to be re-elected in democracies. So this is also a bias or an incentive which needs to be accounted for. And what Alex Epstein did is pointed out the flaws in these 2 steps in the knowledge system, mainly the synthesizers and disseminators. Let me just give you a brief example. So in the climate discussion, the main synthesizer is the IPCC, the Intergovernmental Panel for Climate Change, and they come out with a report every few years. It's a very, very well-known thing. And in this entire report, which discusses the physics of climate change and the effects of the climate on humanity, you, for example, do not see the simple fact that in the last 120 years, the nominal number of deaths from extreme climate events have reduced by a factor of 1/50. So 120 years ago, on average, 500,000 people per year would die from climate disasters, and now it's about between 5,000 and 8,000 people a year, although we have increased the population by 8. And this kind of thing should appear in how climate affects humanity, but it's not there in the science, nor does the fact that, for example, cold kills much more people than hot temperatures, factor of 4 in the Western countries, up to factor of 20 in the developing countries. So you can see the biases in the synthesizer report. They're very obvious. And of course, it's very easy to find examples of disseminators which are completely wrong. I have 2 examples here. I'm going to briefly show them. This is an example from the Israeli paper Globes. It says here, climate change is happening faster than predictions, right? And there's an air of urgency to the fact, but when you go and read the paper, you actually see that this is not what the paper says at all. The paper actually says the inability of climate models to accurately capture the storm track intensity, which delays the detection of intensification in models by several decades, questions the skill of climate models to accurately assess the future changes, etc. So the paper is a scientific paper telling us that the climate models are really pretty bad because we compare the calculation to reality, and there's a very strong discrepancy. And the paper says we shouldn't trust climate models at this point. And the newspaper says, oh, climate change is happening way faster, just because the change was in some positive direction rather than that. It doesn't at all say that. This thing says, here's another amazing example. And Google this. Did you know that 1/3 of Pakistan was underwater in August due to floods? Now, you don't need to be a geographer. Pakistan is a huge country. It's really big. 1/3 of that there is absolutely no way that this can happen. And in fact, satellite data shows that the recent floods were about 55,000 square miles out of total area of almost 800 square miles. So that's about 6 or 7%. It's still a big flood. Still a big flood. But it actually has nothing to do with climate change, because data shows us quite clearly, and this is well documented, that monsoon rains in Pakistan are actually decreasing rather than increasing. And this has to do with the fact that, the people of Pakistan are going into cities and they're building their houses along the rivers, and they are very poor. So they don't have ways to build them very well. So once again, this is, and of course, a million examples in papers like that. That's very easy to find in every field. However, what I want to show you is that Alex Epstein missed 2 extremely important features of the climate system. The first feature is that biases in the knowledge system accumulate. And this is, of course, almost trivial, right? If there's some sort of bias in the research community, then it will be picked up by the synthesizers, right? Simply because they have no choice, right? There are 10 papers, 9 of them say one thing and 1 says the other. It doesn't matter that possibly the one is correct, right? And we all know this can happen in science, right? The fact that something was published doesn't mean that it's true. It just means that it's up for debate. But the synthesizer will have this bias accumulated in the reports. Now, of course, once there's bias in synthesizers, the disseminators, the news outlet, will pick up that bias and enhance it. And of course, once the evaluators see this bias, they will say, oh, we have to spend more money on these 9 out of 10 cases, and they will put money into this. And this brings me to the next inherent feature of the knowledge system, which was totally missed by Alex, and that it's not a linear system. It's a feedback loop system, right? It has intrinsic feedbacks within the different parts of the system, and they are very real and very apparent, right? So researchers and synthesizers are typically the same people or from the same group of people. So they interact with each other. So all the political pressure and the peer pressure that happens here would also happen here. Now, of course, synthesizers want disseminators to acknowledge them, right? They want to be out there in the media. And of course, disseminators put pressure on the evaluators. Now, the evaluators put money back onto the synthesizers on the committees, and they use the authors of the reports as expert advice, right? So that's what? Yes, right. Oh, and this is, of course, the most important feedback, right? That, and I should have put a larger arrow here. This is the most important feedback, because in the Western and practically all over the world now, science is dominated by government funding. So this is a crucial step, and this is what I would like to show, to demonstrate. And let me demonstrate, I'm going to give two examples. And the second example will connect the dots to DEI. Of course, you can look, for example, about what happened to funding for climate research, actually climate crisis research. And this is 1990. And here was the famous appearance of Jim Hansen in front of the US Congress. And then you see a rise of funding, which is about 15-fold. From the 90s up to these days, the funding for climate science has gone up by a factor of 15. That's a really, really big number. And of course, it's reflected in the output, right? What you see here as a function of year is the number of climate change journals popping out, of course, receiving public money. And well, if you have the journals, then they will be filled with papers, right? So you have a very, very, understandable correlation between funding and number of papers and number of researchers and number of departments, and of course, world news, right? So this is a funding, so evaluators, researchers, and disseminators all at once in one grant. So the interplay is quite obvious. It also makes sense. And you can actually see what happens every time the IPCC sends out a report. You kind of see a change. This is most visible here. You can actually see a change in funding and then a change in the number of papers coming out from that same field. So we know that there is a feedback loop. And you can say, okay, fine, the government has a right to put money where it thinks is right. But there's a problem with that, because the first problem of the knowledge system, which biases accumulate. So now everyone is talking about CO2, and very few people are talking about solar wind. Maybe that's more important. We don't know, right? Because a distribution of funding that goes into researching this thing is not uniform, right? So we are hurting science, but we're hurting science in a much, much deeper way, because these kinds of biases eventually diffuse into other ways that we are forced into doing science. And the second example is the meta-evaluator, the United Nations, which has a subsection called UNESCO. This is the UN portion of education. So this is the part of the UN which is responsible for educating the human population on Earth. And they came up with a document describing the sustainable development goals. Basically saying, if we want to have a sustainable development, we want to have a sustainable future, this is what we need to do. Of course, there's a cyclic argument there if you actually read the document, because sustainable development is a development which achieves these goals, right? So, and of course, to achieve a sustainable development, you must have reduced inequalities and gender equality and quality education and good health and zero hunger and no poverty and affordable energy and climate action, of course, and life below water. You know, we have everything that is good and nothing that is bad. It's kind of a ridiculous statement. However, they specify quite clearly what needs to be done. And this is where things become tricky, because you can actually read, these are the links, and there's a document saying this is what higher education institutions need to do in order to move forward to Agenda 2030, to this sustainable development. And this is what it says, right? This is the document. It says, for example, higher education institutions need to use the knowledge they produced and their education of new professionals, so no longer students, but new professionals, to help solve some of the world's greatest problems, as addressed by the SDG document. So the goal of the university is no longer to seek the truth, and it's no longer to acquire knowledge. The goal of the university is now to help solve some of the world's greatest problems. That's a big change of paradigm, right? And of course, make sustainability and SDG literacy core requisites for all faculty members and students, because you must learn about the SDG goals. No matter if you're a mathematics student or a quantum chemist, you must know about the danger of sustainability. And of course, the call this report makes is for the universities to play an active part in an agenda. It's written black and white. I mean, there's no conspiracy here. There's no scheme in some dark room, right? It's out there. If you want, the top institute in the world concerned about the education of future generations is telling us that we must be part of an agenda, no longer seeking the truth, but working toward the agenda that they wrote down. And this is what they say about freedom of thought and academic freedom. The higher education institutions should not cease to protect and expand academic freedom. There should have been a comma here. There should have been a point here, right? No. For the promotion of systemic change. So you can expand academic freedom, but only if it works towards systemic change. It's no longer a must in the academic system, but only if it helps, right? Basic and curiosity-driven research, which is what I do, should also be maintained as a core principle where relevant. Black and white. I mean, it's so I told you this instead laughter, right? Right? It's unbelievable. And then they say, oh, there are ways to ensure that, right? Recommendations for higher institutions. Oh, sorry. Why did I do that? Right? First of all, higher education institutions should consider establishing the post of chief SDG officer or a sustainability committee. What's the word for committee in Russian? Right, the Soviets, right? So we will have a committee telling us whether or not the study of the chiral induced spin selectivity in molecular junctions supports the SDG goal. And if it's not, sorry, you're not going to study that. I know, it's what's interesting to you, but it's just not part of the agenda. And then, of course, the higher education institutions must refuse to engage in research that supports non-sustainable practices. Who will decide whether or not, Riemann elliptic curves are sustainable or not sustainable goals, right? The commissar, right? He will decide. This is the end of academia as we know it. It is. If these goals are accepted, if the university signs this participation in this agenda, it is the end of academia as we know it. It's as simple as that. So, and of course, this is already happening in Barcelona. There was a student riot And of course, the administration caved in. And now all students have to take classes on climate change and sustainability, even if they are studying pure mathematics or quantum chemistry. It doesn't matter. They need to know that the world is going up in flames, right? So this is the system we have. The question is, what can be done? I don't have a lot of answers. I can give my thoughts, and I would love to hear your thoughts. Of course, first of all, we need to be aware of the flaws in the knowledge system. We need to consider those. Every time we read a news article, every time we see a report, every time an administrator in the university comes to us and tells us, you know, give me your expert advice, we need to be knowledgeable about these flaws in the system, and we should try to actively correct these flaws. And as of course, science literacy is a must at all levels of education. This was already mentioned here. This is a big problem. So what can be done, I'm dividing it to 3 levels. On the personal level, what helped me is to study philosophy of science. Actually, to try to understand what it is that we are doing here, what it is that I'm doing that when I'm solving an equation and getting a list of points and comparing them to experiment, what is it that I'm doing? That helped me a lot. And of course, one needs to be aware of your own biases, because we are all human beings and we all work with biases. And knowing that is first step towards avoiding them. On the institutional level, well, we are doing it right now, right? We're organizing resistance to these changes of paradigm in the structure of academia. This is a part of the resistance. We need to debate. We need to participate in committees. We need to participate in Senate committees and engage and object vocally, right? We need to be heard. I mean, the fact that we are all sitting here is all nice and well, but I'm preaching to the choir here, right? We need to send this out to people who disagree with us and debate them and confront them with this paper from UNESCO and tell them, is this what you want for academia in Israel or in the US or wherever? And on the national level and global level, that's very, very, very hard. I don't know what to do. I mean, first of all, we need to participate in funding discussions and politics, right? I mean, there are other models of funding, except get all your funding money from the government. For example, I worked in Los Alamos National Laboratory, and in Los Alamos National Laboratory, you get funding if you work for a goal on some specific project, and then you can get funding to do your own stuff. That's a different model of funding. It's local, but you know, it works. They have fantastically good science. We need to engage in global discussions. Of course, again, I'm preaching to the choir here. Our distinguished speakers are all well known for doing that. And again, we need to object vocally, right? Write papers, interviews, whatever we can to shine light on these things. And I want to finish with a quote from Eisenhower. So he was a smart man, as it turns out. In 1962, he was voted out of office, and in his farewell speech, which is very well known, he writes this: in this technological revolution, research is central, right? Says, today the solitary inventor tinkering in his shop has been overshadowed by task forces of scientists in laboratories and testing fields. In the same fashion, the Free University, historically the fountainhead of free ideas and scientific discovery, has experienced a revolution in conduction of research. This is 1962. See how visionary he was? Government contract becomes virtually a substitute for intellectual curiosity. And he's warning us from 2 dangers. First, the prospect of domination of the nation's scholars by federal employment, project allocations, and the power of money is ever present is gravely to be regarded. So this is from policymakers funding down to academia, but he's also warning us that in holding scientific research and discovery in respect, we should also, we must also be alert to the equal and opposite danger that public policy could itself become the captive of scientific technological elite. And I would change that. He was almost correct. We should maybe write here pseudo-scientific a social elite, but this is the feedback loop, right? This is it. It was already recognized by Dwight Eisenhower in 1962, and this is something we should all think about all the time, I guess. Thank you very much for your attention.